Hello, everyone. Thank you for joining us for our build session creating vector tile sets with the Mapbox Tiling Service. This will be presented by Chris Wong, our Senior Developer Evangelist. But before we get started, I just want to go over a couple housekeeping items. This session is being recorded and the recordings will be available to all registrants. So you can go to the build Zoom lobby, that console where you've been accessing all of these sessions, and the recordings will be available there after the event. We have 60 sessions, so I know you can't attend all of them. So if you miss one or if you want to go back to one that you attended, head to the build Zoom console to see the recordings. For this session and all sessions, captions are available in multiple languages. You can see that image on the right of this slide. You could click the show captions icon and get captions in the available languages. You can submit questions through the Zoom Q&A feature. That's also an image on the bottom right here of the slide. The Q&A is the best way to get a question answered. I will be monitoring it throughout this session, and it's the first place I look to find questions and answer them. Some people have been posting in the chat, and that is okay, and I might look at the chat, but your best chance is the Zoom Q&A feature. And then finally, like I said, there are 60 sessions for this event. We are getting to the end of the week and the end of the event, but there's still more to come. So you can go to mapbox.com/build and see the remaining agenda for today and tomorrow. And then without further ado, I'll pass it off to Chris to get things started.
Awesome. Thank you, Greg. So today, welcome to my session. Today we're going to do creating vector tile sets with the Mapbox Tiling Service. So this is something I've done a good bit. Wouldn't say I'm a super advanced user of MTS, but I've definitely been through the basic setup many times, and I'm using it in a production app that I maintain, which I have a session on later today. So I can tell you a little bit about how to get started. So what is Mapbox Tiling Service? MTS is a set of web APIs for creating and updating Mapbox-hosted tile sets. So in this session, we're going to be covering vector tile sets, but there are multiple types of tile sets that you can host with Mapbox, including raster tile sets and raster array tile sets. Raster arrays are sort of the new kid on the block that allow you to do things like weather animations, where you have like multiple rasters encoded within a single raster. You can do animations and things like that. But vectors are kind of the primary way to get rich vector data. Vector tile sets are the primary way to get vector data at scale into Mapbox maps at whatever zoom level or area you're looking at. And the resulting tile sets that you make with MTS can be used in any Mapbox renderer. So as you're probably already familiar with, if you use Mapbox GeoJSON on the web, or you use our Maps SDKs for iOS, Android, or Flutter, and Flutter is really just wrapping iOS and Android, you can use these tile sets. So we're going to get started with how to actually create one from raw data today. So what's a vector tile set, and why do I need one? So when you load a Mapbox map, your style contains vector sources that tell it which tiles to fetch. Most Mapbox maps use the Streets V8 vector tile set. So the Streets V8 vector tile set is hosted and maintained by Mapbox. It's got all the goodies in it for showing everything we see on the base map. So it's got country borders, it's got land and water areas, it's got points of interest, all that packed into one tile. So we have multiple layers, many dozens of layers packed into a single vector tile. So if you're not familiar with tiling, when you load a digital map, it actually divides up the area of the screen that you're going to be viewing into tile regions, which is a kind of predefined standard or predefined schema for which parts of the world are reflected. So basically mapping the latitudes and longitudes at a particular zoom level to the area you're trying to show on the map. So on the right side of my screen here, you'll see an app called What the Tile. Hopefully maybe somebody can grab a link to that and throw it into the chat, but you can also Google for it. This is actually used internally by a lot of Mapbox engineers in order to get the addresses of these tiles, because each tile that you see on the screen has a unique address corresponding to its X, Y, and zoom level. And then, of course, those boundaries also have corresponding latitude and longitude corners. So every point on the world falls into one tile at a given zoom level. And as you zoom up and down, there's a lot more tiles as we go further down. This is called a quad tree. That's what the image on the left is. So you can see we show the map in, the entire world fits into a single tile at zoom level 0. And then there are literally billions of tiles that you need to represent the entire Earth as you get further down to street level. So Mapbox creates great rich tile sets that you can use to make your base map, or if you just use Mapbox Standard or one of our styles, you're getting all that for free, I guess, behind the scenes. You don't really need to concern yourself with vector tiles. But of course, the minute you want to bring your own data onto the map, you're going to need to think about it again. This is actually a slide from my earlier talk here at Build about adding custom data to the map. So you have lots of options for getting your data in. The three main categories we divide these into are vector tile sets, which you're kind of working on now, GeoJSON sources, which you can have in your code base or locally with your build files, or you can download off the web as a file. And the downside of those is that you have to download all the data. So as soon as you have tens of thousands, maybe even thousands of points, those GeoJSON files can get really big. And the benefit of vector tiles is that you're only downloading the tiles that are in view, which means you may have a huge data set that covers the entire planet and has millions of points on it. If you're only looking at New York City, for example, you only need the 5,000 points that represent New York City. So you're just leaving the rest in off the map, and you don't really need to download them until you need them. So I put a little thing that says you are here because one of the cons of vector tile sets, if you even want to call it that, is that they require pre-processing, right? So you can't just get them for free. You can't just drag in a file and magically a vector tile set appears. I'll catch that statement and say you actually can do that right now. If you go to Mapbox Studio and drag in a file, it'll make a vector tile set for you, but that has some size limitations. So once you're more serious about larger data sets, and when you're more serious about keeping data up to date because you want to kind of replace the data in a tile set, MTS will be your friend. So that's kind of where we are right now, as we know, figure out how we can pre-process our data to make tile sets. So give me 1 second. So the anatomy of a vector tile set. A single tile set can have many discrete layers. Like I said before, the Streets V8 tile set that Mapbox uses has dozens of layers in it. So all those are curated differently, maintained differently, and then they come together to make a single tile set where each tile has multiple layers in it. So the simplest way to think about this is, like, for example, if we have roads, water, points of interest, and buildings, we can smush all those and flatten them together into a single tile set. So the browser makes one request, which is an MVT file, Mapbox vector tile. It contains many layers of data. You can control which layers are available at which zoom levels. So you may only need water at the highest zoom levels, and you may only need roads at the lower zoom levels. So that's why when you zoom in and out of a Mapbox map, you may see roads disappear, you may see labels disappear, and it's a very good chance that they are actually disappearing from the tiles that you're downloading, because we don't want to pull anything into the browser or into the client that isn't needed. It saves a lot of bandwidth and keeps the tile sizes smaller. Basically, anything that's not necessary at a particular zoom level can just be filtered out. Lastly, you add layers to the map style using one source layer. So you may download an entire vector tile. For the example shown here, if you only needed roads to show, you get all the rest of that data, but you don't necessarily have to visualize it. So you have to specify which layer inside the tile you want to visualize. We're going to do that today in the demo. Tileset sources are an important concept here. So if you saw on the last slide, we have multiple layers in a vector tile. We call that in MTS parlance a tileset source. So tileset source corresponds to a layer in the tile. To make a tileset source, you need to upload data in a very specific format called GeoJSON LD, or line-delimited GeoJSON. So I have a little picture of what that looks like in a file on the right here. It looks just like regular GeoJSON, except that instead of wrapping all of these features into a feature collection, we just put one feature per line, and that's it. So we know every single line is a discrete feature. It needs to be valid GeoJSON, so it needs to have a geometry, it needs to have properties. There's no comma after it, so it's not like a comma separated comma delimited. It's literally just one feature on each line. So this will take a little bit of processing, and I'm going to show you in the demo how you can convert from a normal GeoJSON file or from a shape file to get GeoJSON LD. And you can see the extension there is GeoJSON LD. Each tileset source gets a unique ID, and it will correspond to a discrete layer in the vector tileset. So like I said, if you want, you can make a vector tileset with just one layer in it, or you can make one with 5, 10, or a dozen layers in it. And it's about whatever you need. So you want to make sure you're being optimizing how you want to prepare your data so that you can, keep network traffic to a minimum and get the data that you need into the client when the map needs it. Okay, so like we said, you upload your vector data to make something called a tileset source. Then you define a tileset. So we have multiple tileset sources that go into a tileset, and to do that, we use something called a recipe. So I'm showing a example of a recipe.json here on the right, and you can see, for example, I am referencing two sources, one called roads and one called water. Each one of those sources has a Mapbox URL, so those need to exist first. Once they exist, then I can submit my recipe and say, hey, MTS, please make a tile set out of these two tile set sources. Once I publish that, so creating the tile set is really just uploading the recipe. And then processing the tile set is when you actually will it into existence and say, okay, now actually put all this data together, host the tile set, and out the other end comes a tile set ID, and that's what this URL is at the bottom here. And this is all you need to actually use the tile set that you just created in a front-end map. So it can take a little time, right? So what I'm going to show today probably has a few hundred, maybe a few thousand features on it. It's going to take a couple minutes to process. So if you scale that up, you may have a build time that may take half an hour, could take hours. It all depends on how big your data is. And we also have incremental updates, which we're going to do a whole different session on later this afternoon. And that will let you make small changes without having to reprocess the entire tile set, which is a huge time saver. That's a new feature that just came out this year. And yeah, I'll do another session on that this afternoon. So once you have your tile set published, then what do you do? You can either add it to a style in Mapbox Studio, or you can add it to a style of a map that's already running at runtime. And I'm showing a snippet here of using add source and add layer. If you've ever used add source and add layer in Mapbox GLJS using a GeoJSON source, it's really the exact same syntax, except it's a vector source and not a GeoJSON source. And instead of pointing it to a GeoJSON file, we point it to that tileset URL, which is what you're seeing here next to the URL field. So those are really your two options. Your tileset exists. You can actually use it in third-party tools because it's a hosted tileset that matches the Mapbox vector tile standard. So you can pull them into QGIS if you want to. There's lots of other third-party tools that can consume vector tiles. But most people probably just want to use it in the Maps SDKs or Mapbox GLJS. Okay, so for updating a tileset, you can append or replace data in an existing tileset source. So if I upload a tileset source and make a tileset out of it, I can just overwrite that tileset source and then just say republish the tileset. So for the end user, for the client, nothing will change. Everything's still accessible by that same tileset URL. But behind the scenes, you can kind of keep updating the data as you need to and republishing. And this is where MTS gets really powerful because you can set up complex data pipelines around it, automate the data flowing out of your database into Mapbox to host these tiles, etc. So won't get into that much today. We're just going to set up one tile set and use it, but I think you'll get an appreciation for how you can automate this, I think, a little bit during this session. Okay, Tileset CLI. One more concept we need to be familiar with before we start the demo. So MTS is just a series of APIs. So you can check out the documentation for MTS, and you'll see, there's lots of documentation for how to do curl requests or do post and get requests to get certain things. So Tileset CLI is just a command line tool that's Python-based that helps us automate this a little bit and gives us some syntactic sugar to interact with MTS. So instead of having to memorize really long URLs and figure out, which URLs we need to call, we can just run things like I can run tile sets. What can I say here? I can say delete. I can say list. I can say update recipe. I can say view source. So you're going to see me run some of these commands. So you have to install this separately, but once you have it installed, it can be very powerful in helping you automate this, you're getting your data into MTS. Lastly, tokens and scopes. So in order to interact with MTS, you need an access token, which is a secret token. So if you've used our front-end mapping libraries and SDKs before, you've probably used a public token, and that's how we keep track of map loads and things like that for your usability. Sorry, for your user, how much you're using. But in order to interact with MTS, you need to have a secret token that has tilesets write, tilesets read, and tilesets list scopes. So if you log into your console, you can create a new access token, tick these boxes, and be careful. Secret tokens are only shown to you once. You're supposed to copy them, keep them somewhere safe. But once you have that, then you can start using Tileset CLI. Okay, let's build. I'm going to move over to my environment. Let's see, I have a VS Code environment up here. Let's zoom in a little bit so you can see things a little bit better. Okay, so what I want to do here is I have two open data sets. So I'm going to show you where I got them from. They're both from the New York City Open Data Portal. I'm here in New York and familiar with some of this data. So one was this Parks Properties map, which I downloaded as a shapefile. So you can see it's got thousands of polygons in it for parks all over New York City. Secondly, there's another data set called School Points, which is a GeoJSON file. I think people couldn't see VS Code, so hold on, I'm going to stop sharing. Let's stop sharing and let's share my whole screen. Okay, there's VS Code. Can you see it now? Let's close you. Okay, thank you. All right, so those are my two data sets. So like I said, we have the ability to put multiple layers inside of a tile set. So these are going to be my two layers. I'm going to have a schools layer and I'm going to have a parks properties layer. So one point data set and one polygon data set are going to go into my tile set. So let's go back over to VS Code. And here in my data directory, I've got these two files. So one was a shapefile. If you're familiar with shapefiles, it's actually multiple files, usually zipped. And then the GeoJSON file here, without any line delimiters in it, is one giant feature collection with all these parks properties. I'm sorry, I got them reversed. The school points are a shapefile of points, and then the parks properties is a GeoJSON file. So to convert these, there's a few different options. I think in other demos I did during build, we used QGIS, where you can open them and just export them using a graphical interface. But today I want to show you a tool called OGR to OGR, which is part of the GDAL tools. So I have some commands ready to go, but this one I'll start with, convert schools shapefile to GeoJSON LD. OGR to OGR, I can just pass in -f, which means which file I want to read, or sorry, which format. So it's going to say GeoJSON SEQ. GeoJSON SEQ means GeoJSON sequential, which is the same thing as GeoJSON line delimited. So that's a little confusing. Then I tell it which output file I want it to write. So it's going to write school points aps.geojsonld. And then this is the input file. And then here we have a SRS, which is the coordinate reference system to use. So it's going to export in EPSG 4326, which is latitude and longitude, which will be compatible with our Mapbox maps. So turn your attention over here to the data directory. When I run this command, you'll see a GeoJSON LD file magically appear. Did it work? Unable to open data source. Did I not type it properly? Data. Oh, it's doing .zip. Sorry. I wrote this and then I fixed it. So this should be .shp because it's a shapefile. Still didn't work. Hold on, let's try this one more time. Vector MTS data slash School points. So I'm in a directory. Sorry. Now school points dot shp. There we go. Okay. So this file just magically appeared, which is our GeoJSON LD output. This is the output of the OGR to OGR command. And just to get a little peek at this, like I showed earlier, we have each line of this file is a separate GeoJSON feature. If we scroll to the end, we'll see that there is no comma. So that's all it is. It's just one line per feature. And just to sanity check this, I'm going to come over to geojson.io. What I really want to look for here is that my coordinate reference system conversion worked. I am seeing latitude and longitude coordinates in this GeoJSON feature that I just copied, and it is appearing in New York. So I have reason to believe that it translated properly. So that's great. Okay, I'll look at my second command here. So this one, we're converting a existing GeoJSON file into a GeoJSON LD or line-delimited GeoJSON file. So again, direct your attention. Hopefully I got the directories and everything right here. But direct your attention over here to the data directory and you'll see another GeoJSON LD file appear after this command runs. There it is. So here's our parks properties. So same thing. This is now a line-delimited GeoJSON file ready for import into MTS. And I'm going to select just one of them at random. And we'll go back over to GeoJSON.io, paste it in to sanity check it. We got a nice polygon somewhere here in the Bronx and lots of property data, which I'm going to end up uploading to MTS, but I probably don't need all of this, and that's going to make my tile set bigger than it needs to be. So if I were doing this for real, I would cull some of these properties, but we don't need to mess with that right now. Okay, we've got our data ready to go. So that's the first step, is get your data into GeoJSON LD format one way or the other. OGR to OGR is extremely helpful. You have to learn the syntax a little bit, but AI can definitely help with that. Okay, now that our GeoJSON LD exists, we're ready to make some Tileset sources. So if you recall from the presentation, we have to upload these GeoJSON LDs and name each one as a Tileset source. Tileset CLI is going to be our friend. And if you notice here in my terminal, if I type Tilesets, it's going to list all my different command options for the Tileset CLI. An important step I need to cover is that you need to set an environment variable for the Mapbox access token. Otherwise, you would have to append the token to every single command in the Tileset CLI, and I don't want to write that much or paste that much. So if I do export Mapbox underscore access underscore token, all caps, equals, and then I have it kind of saved here so I can copy it. Here's my secret token. And if I set that once, let's see. Yeah, if I set that once, now I should be able to run these tileset commands. If you haven't set it properly, when you try and run the command, it's just going to say you need a secret token. So you either didn't set it properly, or if you're trying to append it to the command as a flag, you're maybe using the wrong token. All right. So I have a few more commands kind of ready to go here. So creating tileset sources. So the command is tilesets, which is a tileset CLI. Upload source. I'm just going to retype it so I can talk. Upload SOURCE. So we're going to do the upload source command. I have to give it my username, which is Chris Wong Mapbox. I'm going to call it NYC School Points. So I'm giving it a useful name. And then I'm pointing it to the GeoJSON LD file that has my data in it. And if I hit enter, we should get some feedback that this is uploading. So this is now calling a MTS endpoint behind the scenes. It's creating a tileset source with this ID, which is mapbox : / tileset source / my username / the ID. So this is important because this URL is how I'm going to reference this tileset source when I make my recipe. So I'm going to leave that here, and then I'll run the next command, which will upload the second data set. So this will be the parks properties, which is polygons. And again, tilesets, upload source, my username, the ID that I want to give to this tileset source, and then a reference to the file, the GeoJSON LD file. Okay, this one's a little bigger, so I'm actually not quite sure why it's not showing the actual progress, but c'est la vie. Here we go. So it's been uploaded. And again, we have another ID here that I can use in my recipe. So maybe a little hard to keep track of these, right? Because there's no graphical interface right now to list these tileset sources. But we do have the tileset CLI, which has a list command. So let's do tilesets list Chris Wong Mapbox. I'm sorry, those are the tilesets. I don't want the tilesets. I want the was it list sources, I think. There we go. So this is showing me all the tileset sources that I've ever uploaded in my account, and you can see the ones that we just did right now are right here at the top where I expect them to be. So I've got a bunch of other ones in here from when I've been doing demos, and a couple of these are actually used in production for an app that I maintain. So this is great. We're in good shape. Our tileset sources are updated. So now that we have our sources exist, so we converted our data to GeoJSON LD, we uploaded that data to create two tileset sources. Now we need to create a recipe and to define the tileset. So I'm going to click here on recipe.json. I have to make a quick correction here because you can see this is just a JSON document. It's got a layers property. In that layers property, we have multiple named layers. So these are the tileset sources. For some reason, I left this one as roads because I was doing another example. So I'm going to call this one schools. And then this one I'm going to call parks. So this is like the ID of the layer, and that's what it's going to be called when I reference it in the front end when I want to visualize it. Here is the source. So here is that Mapbox, Mapbox / ID that you saw when we uploaded the tileset source. And same thing for the parks. Now we have a min zoom and a max zoom. So remember, if you set min zoom to 0 and max zoom to 18 or 20, you're going to be defining billions of tiles. Well, if you have global coverage. So these are only in New York City, so they're not going to be quite billions, but I still don't want a full zoom range. I don't need these to be visible when you zoom all the way out to see all of planet Earth. So in both cases here, I'm just going to limit it to zooms 10 and 16. And what's actually interesting is that Mapbox GLJS and our mobile SDKs will overzoom. So if I zoom past 16, the data will remain available. If I zoom out below zoom level 10, you'll actually see that the data disappears. So this is all you have to do for a recipe. This is a very basic one. There's a lot more you can do inside recipes. You can add filtering. You can do. This is also where you do clustering. So there's a whole kind of syntax to learn in order to get this right. So you should check out the documentation and start learning the recipe syntax. But this is enough to just get us started. So what do I do with this recipe? Let's go back. Let's save it, and let's go back to my little README here. So now we're going to do another command, tilesets create. So in this case, we're going to name the tileset. So the tileset ID is a compound ID. So it's the combination of my username, Chris Wong Mapbox, with a dot, and then the name of this individual tileset in my account. So I'm going to call this one NYC-combined because I'm combining two data sets. You can do the name flag, and the name flag is going to give it a kind of human readable name instead of this, more machine readable ID. So I'm going to call this one combined NYC open data layers. And then you have to point it to your recipe file. So I'm just going to say -- recipe, recipe.json, which is going to read the recipe right from this JSON file that I was showing you. And that's all there is to it. So I'm going to paste this in, and we'll see our vector, a tile set will be created. So remember, creating the tile set is really just sort of defining the recipe and uploading that to MTS. It won't actually process until we hit publish. So let's run this command and see what happens. Okay, so the message we get: successfully created empty tile set, Chris Wong Mapbox.nyc combined. Publish your tile set to begin processing your data into tiles. So thank you for the very helpful commands, or very helpful responses. And the very last step is to publish the tile set. And I seem to have forgotten my command here. So I'm just gonna, let's see, refresh my memory. It should just be tilesets published, but let's do tilesets-h to get the help list. Whoops. Tilesets -- help. So yes, tilesets publish is all we need to do, but I can still get help for that one. So let's do tilesets publish help. This will remind us of the syntax. So usage, tilesets publish options tileset. I don't think I need any options. Yeah, I don't need any options, so I'm just going to list the tileset ID. So we'll say tilesets publish Chris Wong Mapbox dot NYC dash combined. I think that's it. Okay, tileset job received. So again, this is going to take a couple minutes. What's actually fun is you can go to your console. So I'm going to go to my Mapbox console and let's click on Data Manager. And we should see a little pop-up here. Yep. And so this is where we can kind of connect all this kind of command line stuff and API stuff that we're doing behind the scenes. Now there is actually a GUI. So all the tile sets you see listed in your Mapbox account are indeed the same tile sets you can make with MTS. So you can drag data into the user interface here and make a tile set. But MTS is kind of the more advanced way to do it. And if we want to keep it up to date, we would need to do it that way. But this is great. So it's now processing here. This is a good way to sanity check that, the thing is still running. So I'm going to come back here and just wait. It should take about 2 minutes for this data, which I tested earlier. So we're going to hang tight while this processes. Talk amongst yourselves. Let me see if there's anything else I wanted to show while we're waiting on that. Yeah, let's take a look at the docs. So this is the documentation page for Mapbox Tiling Service. Remember, there's multiple kind of sections of tiling service. So you can do raster MTS and vector MTS. So vector MTS down here is where you're going to see information about the recipes. So this will tell you what you need to know. And then there's a whole API reference for how to actually talk to the APIs if you want to do that directly with curl requests or whatever. If you're not using Tileset CLI, but Tileset CLI makes things a lot easier. All right, let's go back and see if that's done processing. Still processing. I think there's also, what I can show you is there are commands you can run for jobs. So here's my job. Oh yeah, it's giving me the command I need to run. So you can say tilesets job, and this would like poll MTS to see how the job is doing. Whoops. Oh, is it because I had a trailing space? Let's try that again. All right, so returned a bunch of JSON that was not formatted. I could pipe that into JQ maybe, but oh, it says stage success. All right, let's go back to the UI. Succeeded 2 minutes ago. Thank you. This is great. So combined NYC open data layers. So there's that human-friendly name that I put in. And if we click on that, we can now explore this tile set. So this is like the data, this is the data-friendly view where nothing's really styled other than this kind of basic styling, so you can explore it. So we can actually see, this is a parks polygon. We can look at all the properties of this polygon. We can see this schools point layer has lots of great properties in it. So this is called Yorkville Community School. So I'm sanity checking my data. It looks like everything made it in properly, and I just made a tile set. We've also got a nice little graph over here that shows us at each zoom level how big these tile, or what the average tile size is and the max tile size. So you can check this out. But this tile set's ready to use. So again, if we grab this tile set ID here, that's all we need to make use of this in a front-end application. So I have ready to go here. Oops, I'm giving away the secrets. We're going to delete this code. And we're going to start from scratch. Okay, so I've got a Mapbox GeoJS map here, and I'm going to run that. And we're going to use this tile set that I just created. Okay, so here's my map centered on New York. We're just loading the Mapbox standard style, and we haven't done anything yet. And let's do a little bit of front-end coding here. So we're instantiating the map. Then we have this map.onload event. So when the map loads, we want to load our tile set as a vector source. So we're going to say map dot add source. Let's call it NYC combined. And then we can say it is of type vector. And I think it's just remembering this from the last time I did this demo. So we need mapbox / Chris Wong mapbox.nyc combined. And this is the tile set that I just published before your eyes. And again, if you add a source to a Mapbox GLJS map, it will make no change in the map because you need layers that correspond with it. So I'm going to let Copilot fill in this add layer statement, but let's see. We're going to give it an ID of parks layer. It's going to be a fill. The source will be NYC combined, which is the same source I added up here. Then there's a source layer called parks. I think Copilot knew this because it has access to the recipe, so it knows exactly what to call it. So again, this layer is going to visualize only one of the internal layers of my tile set, which will be the parks layer. It's going to give it a nice green. Thank you, Copilot, for knowing that this is parks. And here we go. So these are now sort of neon green. We have to go looking for them. But I'm not going to do a whole lot of styling here. I just want to show you that this exists. And then secondly, we can add another layer. Let's format this a little bit. Okay. And it already knows what I want to do here. So we're going to say ID of schools layer. This will be a circle layer. And we're going to change from the internal layer inside the tile set from parks to schools. And let's do circle color of red. So we're going to make a bunch of red circles with a radius of 6. And here's my data. So I zoom out past zoom level 10, everything disappears. But when I zoom all the way in, you'll see, I mean, our recipe said, don't make tiles for these past zoom level 16. But as we zoom all the way in, we still see the polygons and points. So that's called over zooming, and it's not requesting any new tiles. It's just using the tiles that it had at zoom level 16 and just rendering them as we get even closer. So there you have it. If I were building a real app, I would style the heck out of this and make it look beautiful. But we just took these two New York City open data sets, created GeoJSON LD from them, created Tileset sources from them, wrote a recipe to combine those two Tileset sources into a vector tileset. We published that tileset, and then we got the tileset ID to use in our front-end code as a vector source. So that, I think, will end my demo. And I think we have time for some Q&A. So let me stop sharing.
Thanks so much, Chris. I say this every time. I'm always super impressed when we go live with the demo. It's definitely a challenge to go fully live, so that was awesome. We have had some questions, so I'm going to start passing them to you. Some of these have been answered, but let's answer them live.
All
Uh,
right.
can we do this tiling in Mapbox Studio instead of the Tileset CLI?
So in Mapbox Studio, um, you're limited in your options, right? So I showed you an example here of combining two different data sets into a single tile set. If you drag a file into Mapbox Studio, it will make a tile set for you, but that's all you get. So you get one data source into one tile set. It's a great way to get started quickly, and you can start styling it immediately in Studio. But the actual creation of the tile set, you don't have as much control over, and you can't put like multiple data sets into a single tile set using that user interface.
Okay, awesome. And kind of related. So if you're using MTS and you tile, is all the styling done in the front end code?
Yes, that's kind of the beauty of vector tiles, right? That was the innovation, is that in the old days, when web maps were younger, and I was younger, um, everything was raster based, right? So you needed a server to take vector data and style it and make a pretty picture of a map, and then you had to move that picture down into the client. That's how raster tiles work. But you would take you would take vector data, rasterize it, and then bring that raster picture of a map down into the client. So the whole innovation of vector tiles is that we're doing the rendering in the client. So that's how all of Mapbox's map renderers work, is they download these tiles that have rich data in them, but no styling information. And then they do all the colors and the fading and all that stuff happens in the browser. So yes, you have to do it all in the client.
Okay, Great. Here's another question. Is there an easy way to add a layer list to the front end to, for example, turn on or off each layer?
Uh, Man, I'm tempted to just do this right now with AI. Um, and you know what? Screw it. Let's do it. We got some time. So let me share screen again. I would say no, there's not an easy way. You would have to code it. But maybe there is now with AI. So make a simple layer toggle UI in the upper right hand corner to toggle my two layers on and off. All right, fingers crossed. We're vibe coding. I actually have a session on vibe coding with GLJS tomorrow afternoon. If you want to tune in for that, I'll be doing exactly this sort of thing. But let's see how far this AI gets us. This is using yeah, GPT 4.1.
Chris, if we think this will take a minute, I could toss you another question.
Give it 5 more seconds. It shouldn't take this long.
Okay.
That's disappointing. Okay, fire me another question.
Is it possible to automate the creation of tile sets or to automate adding sources to an existing tile set?
Yeah, so it's all config driven, right? So you can write scripts to do all this stuff. So for example, yeah, so you can write a script that'll convert your data into GeoJSON LD. As long as you know where you put that file, then you can run more commands to make sure all those get updated. I also showed you can use Tilesets CLI in order to get the status of everything, so you can double check that the Tileset sources were uploaded properly before you make the tile set. So yeah, you can automate all of that. I wouldn't say there's any special tooling for that. You would just need to use whatever scripting environment you want. I would use Node. You could write Python scripts. You could write shell scripts, whatever automation you want. Okay, let's run that. I didn't even check it, so let's run it and see what this thing did. Okay, look, we got a parks toggle. Look at that, and a schools toggle. So thank you, AI. So the answer is yes, it's easy. Let's take a quick look at what it actually did here. Yeah, so this is just vanilla JavaScript, but it said add event listener. Here, let's toggle this. Do you have another question, Greg?
Yeah, can we attach an event to a feature in tile sets?
Attach an event to a feature. Here, let me stop sharing because this is distracting us, but I'm glad we got that on air vibe coding working. Sorry, one more time.
The question says, can we attach an event to a feature in tile sets?
Attach an event to a feature. So it sounds like you want to do interactions, like you want to know when somebody clicks or hovers on a feature, and that's all done in the browser. So what you can do in the tile set is set up things called feature states. No, that's not true either. That's done in the style. So no, I don't think so. I think all that needs to be done in the browser.
Okay, and Krishna, if you want to elaborate a little bit, you could post a little more explanation in the Q&A and I can read it. Um, for example, I want to move a position of a point on runtime.
Ah, well, no, what would probably make more sense in that case is because you can't really update, you can't set data on a vector tile source on a vector source. So it's all kind of once it's there, it's static. What I would probably recommend doing is if you want, if you have a point showing on the map that came from a vector tile, uh, and you want to move it, you could listen for a drag on that and then add a marker or add another kind of temporary, like a local GeoJSON source, and actually filter out the point as it existed in the tileset source. So you could, or the tileset, so you can move and hide it, and then just draw a new one that's sort of a working point, a working like a GeoJSON source that is like a working source, right? So it's a little bit of trickery, but you can't really change the vector tile data after it comes in to the browser.
Okay, yeah, and Jonathan offered as well query rendered features at runtime, then attach interaction handlers to a tile set. They do it frequently.
Correct. And query rendered features is kind of the older way, and then we have the new add interaction API, which came out I think earlier this year or maybe last year. So does the same thing, but slightly different syntax and slightly fewer lines of code.
Okay. We've had a pretty active chat, but I see no more open questions. So I'll wait 1 more minute and just give a couple plugs. And if you do have questions, get them in. Thank you for joining us. As Chris has sort of alluded to, we do still have about a day and a half remaining of sessions for build. Chris is doing a vibe coding with GLJS session tomorrow, I believe, right, Chris?
That's right.
And then we are also having some community-driven sessions coming up. So customers actually telling their story and how they're building with Mapbox. So those should be exciting as well. So make sure you check the build lobby. And while I was stalling a little bit there, we did have another question come in. Would you recommend using the MTSDS data sync repo?
I don't think I'm familiar with that. So I'm gonna say no comment at this point in the live chat, and then I'm gonna go Google it right after we're done.
Yeah, MTSDS. Okay, I'm going to wrap it up there then. Thank you everyone for joining us, and we hope to see you on future sessions.
All right, thanks.